Hey guys, let's continue. So today we will tackle the method of multiplier. This is also for the form PP plus QQ is equal to R. And we will be writing the same auxiliary equation, which is dx by P is equal to dy by Q is equal to dz by R. Except now we will also equate this as LDX plus MDY plus NDZ divided by LP plus MQ plus NR. This is actually a rule of mathematics. When two things are equal, then the addition of their numerators with a constant and their denominators with the same constant is also equal. So just remember this. We have multiplied L here, M here and N here, and we have added them in both the numerator and denominator. So now what we will do, we will choose L, M and N such that this becomes 0, such that LP plus MQ plus NR becomes 0. Then we will take this numerator and we will integrate LDX plus MDY plus NDZ is equal to 0, because this 0 will go over there. So it will give us this equation and then we will integrate it to get our answer. Generally, you need to find two solutions. So we will take one LMN and then we will repeat the process with one more L1, M1, N1 and then repeat the process. So let's take an example so you can understand better. Y plus Z P minus X plus Z Q is equal to X minus Y. So this is our capital P, this is our capital Q, this is our capital R. So let's write the equation. Dx by y plus z is equal to dy by minus x plus z is equal to dz by x minus y is equal to L dx plus M dy plus N dz divided by L times y plus z minus M times x plus z plus N times x minus y. So now let's look at this denominator and choose elements such that this becomes 0. So here I can see if I take L is equal to M is equal to N is equal to 1, this will become 0. Let's try it out. So y plus z minus x minus z plus x minus y. So all of this gets cancelled out and this gives you 0. So let's plug these over here. So it becomes dx plus dy plus dz is equal to 0. So let's integrate this. Integral dx plus integral dy plus integral dz is equal to integral 0. So this gives you x plus integral dx, you can write x plus y plus z is equal to c1. This is your first solution. Now let's try something else which will create this term into 0. So here you will have to think and put the terms such that this term becomes 0, because that is your main goal. So let's try L is equal to x, M is equal to y and N is equal to z. So this won't work. Try minus z. So let's try this. X times y plus z minus y times x plus z minus z times x minus y. xy plus xz minus xy minus yz minus xz plus yz. So this gets cancelled, this gets cancelled, this gets cancelled. So this works. So now let's integrate. X dx plus y dy minus z dz is equal to 0. Now let's integrate this. X square by 2 plus y square by 2 minus z square by 2 is equal to c2. So let's take the 2 over there and write a new c2. So this becomes x square plus y square plus z square is equal to c2. So your final answer becomes phi of x plus y plus z, comma x square plus y square plus z square. Sorry, minus z square. Is equal to 0. This is your answer. Check out my notes for more practice questions, and if you have any doubts with this one, leave it in the comment section and I'll answer.